Okay, let's discuss this question. 261 graph value tree. So it means that he's going to give you different edges, and you have to decide if this graph is a tree. So what is tree? So this can be tree, right? And even this can be tree. This can be tree. That also can be tree. But in what condition it cannot be tree? When you find a circle. So here we find a circle. So it is not a tree. So the the data structure we're going to use is we build a map. We build a map using the undirected edges, and we find a circle in this graph. If we cannot find, then it is tree. And also all the nodes, they are connected. For example, if later you find except this connection, you also find the other connection, but the two groups, they're undetached. Yeah, so they are detached. So in this case, they are not true too. Okay, let's go into the code. We're going to use the BFS. Firstly, we define the graph, and the graph is array list, and the element is a set. Okay, and then for each node, the graph will assign an empty hash set, and then we get the edges and add the second element as the neighbor. So basically, each node has its own neighbors, and it is a visited. So then you have a queue. A queue at the first element, which is 0. So the first node added a 0. And if it is not empty, we pull the node. And if we found the node was actually previously visited, and then we have to return false, because suppose you are not going to returning back. For example, you have this kind of tree, and for each tree, if you visited for each tree, if you also already visited, and then later you removed the node from the neighbors from the neighbor's neighbor. Okay. Okay, so in this way, then you get the neighbors, right? You get the current node's neighbor, and for each neighbor, you assign to the queue. And the graph get neighbor. And the graph get the neighbor. So it means the graph get the neighbor's neighbor, and the neighbor's neighbor should be removed the current node because it is already visited. So for example, we start from here. So these two neighbors should remove this as their neighbors so they can move forward. So in this mean, if this node is actually connected to this neighbor, and then when I move to here, I continue from this one, then it is a circle. Otherwise, there's no connection here. So when I move forward, I will never find the previously visited node. Okay, so that's the solution. So let me explain again. So basically, you are going to visit if you found the node was actually visited before, then you have to return false because it is a circle. Otherwise, you are going to set this node as true, and also get the neighbors, and also you get neighbors. You offer this to the queue, and then you get your neighbors collection, and then remove the current node. Fully connected. And if you and then um, we check all the visited. If there's one node is not actually is not visited before, then you have to return false because it's a separate connections. For example, you have two trees, so you have two connections. They're in the same connection, but they're separated. So these two cannot build a tree. Maybe they're individually a tree, but they are not tree. So then return for true if there's no problem.